You now know how the localizer and the glide slope combine to lead you out of the sky to a close-up view of the runway numbers. While the magic beams are doing that, though, it would be comforting to know just how far you are from that wonderful moment when you reach decision height and see the runway through the fog. Knowing your distance out gives you valuable cross-checks between your altimeter and your glide slope indications, and that gives you a good handle on how near you are to that decision altitude missed approach point. You're already familiar with a bunch of navigation equipment that could be used for this: DME, GPS, NDB, VOR radials, radar, and so on. Well, we'll talk about just how to use them later on. But first, let's talk about a classic distance indicator you haven't met before, the marker beacon. Here on the ILS runway 14 approach to Mobile, Alabama, you see a couple of them. Marker beacons are little low-power transmitters located along the approach course. Their antennas send a narrow beam of radio energy straight up through the approach path. That energy is coded to trigger the proper light and audio on your marker beacon receiver. Now, this energy pattern is very specific, and the boundaries form a sort of lens shape in the plan view. The classic distribution of the marker beacons places one marker beacon, called the outer marker, about 5 miles from the runway threshold, and another marker beacon, the middle marker, at about 1/2 to sometimes 3/4 of a mile from the runway threshold. At airline airports, like Fort Wayne, Indiana, you'll sometimes find a third inner marker right at the threshold of the runway. It's used by the folks in the really big iron to get really low minimums on the approach. As you pass over the marker beacons, the audio tones get progressively more excited as you get closer to the runway. Passing over the outer marker triggers the blue marker beacon light, and you'll hear a series of dashes at a rate of about 120 per minute with a low audio tone. Passing the middle marker gives you the amber light, and you'll hear dot dash at a higher pitch. The inner marker, if there is one, lights the white light, and you'll hear a rapid series of dots at a higher pitch yet. Now, just in case this sequence gets away from you, Jet prints it out right here in the profile view. Fortunately, you don't have to tune a marker beacon receiver. Just make sure the audio is selected on your audio panel and set the sensitivity to low. Okay, let's take a look at the Mobile plate again, up here inside the outer marker symbol. If you look closely, you can see what appears to be an NDB symbol embedded in it. And sure enough, it ties to this box up here that gives an NDB frequency, 248 kilohertz, and a Morse code identifier, MO. Now, the MO comes from the first 2 letters of MOB, which is the identifier for the ILS. This is the standard ID naming convention for NDBs at the outer marker. If the NDB had been located at the middle marker, as sometimes happens, it would have had the identification OB from the last 2 letters of the ILS's identifier. Now, also in the box is a typical 5-letter name, WISL, and a notation up here that tells you that it's an initial approach fix. Now, the LOM stands for Locator Outer Marker, because the official name for an NDB that shares a marker beacon site is a compass locator. A charming anachronism probably left over from the days when ADFs were called radio compasses. But anachronism or not, an NDB co-located at a marker beacon site can do a lot for you. Using our example here of Mobile, you can see that there's a feeder route coming off of Sims Vortac, and there's another feeder route coming up from the Brookley Vortac. ATC could say cleared direct whistle, and you wouldn't have to track to a VOR first or wait for a vector. Just put the ADF needle on the nose and go. Even if you had to fly one of the published transitions, it would be a lot easier with the ADF needle pointing at whistle. If you're getting vectors to the ILS Final Approach course, the ADF can keep you oriented by pointing at the outer compass locator, wherever the vectors might take you. It also can help you anticipate localizer interception when you're on the final vector. Finally, the NDB can take the place of the marker beacon in the event that either the ground transmitter or your marker beacon receiver in the airplane is out of service. When the needle swings from the top of the ADF indicator to the bottom, you know you've passed whistle. Now, the two marker beacons and compass locator pretty much made up the standard configuration for an ILS installation when they were first being put in service during the late 40s and early 50s. Most of the distance measuring systems that we mentioned earlier, DME, GPS, VOR radials, or approach radar, for instance, hadn't been invented or were just being developed then. So while the two marker beacons and compass locator system is still regarded as standard, classic might be a better word. Many modern ILS installations will be missing one or two or maybe even all of the classic distance determining elements. But it doesn't take much imagination to come up with ways that modern systems could give you your location along the ILS approach course. For instance, some ILS localizers have a DME paired with their frequency, just like a Vortac. You can tell that when you see a channel number in the localizer identification box. Just tune in the localizer frequency to get the DME if it exists. Now, on the JEP chart, it's easier to recognize when there's DME on the localizer frequency because it says so right above the identification box. Some folks are surprised when they arrive at the threshold of a runway that has one of these DME installations and find that they do not get a 0 reading. Well, that's because the DME antenna is located past the far end of the runway near the localizer antenna. What you'll read at the threshold then is the length of the runway plus an additional 1,000 feet or so expressed in miles and tenths of miles. Another interesting wrinkle in DME use happens when the approach designer uses a DME that is not part of the ILS system. That's what they did here at Fort Wayne, Indiana. If the Vortac happens to be located on the airport, as the Fort Wayne Vortac is, the DME distance reading, like this 6.5 at the outer marker, still gives you a fair, although not exact, idea of how far you are from landing. But sometimes the approach designers use a facility that is located well away from the airport, like on this approach to Sacramento Mather Field. With the distances coming off the Sacramento Vortac way over here away from the airport, when you arrive at the threshold, you would see a DME reading of 14.6 miles. And for instance, if you have the localizer needle centered and the DME reads 18.6 miles off of Sacramento, you're here at J-Long intersection. Furthermore, you also know then that you're exactly 4 miles from the threshold because the chart makers helpfully noted it down here at the bottom of the profile view. Now, just in passing, notice the word radar at J-Long intersection in the profile view. You'll see that same note of radar up in the plan view also. That means that the approach controller's radar can also verify that you're at J-Long intersection. Now, there's a big, bold note in the plan view, radar or DME required. And it means that either you must have DME or the controller's radar must be up and running. If not, you'll have to take your Skyhawk and go play somewhere else. Now, if you have an IFR-approved GPS, you can use it to substitute for the DME information from a VORTAC or a VOR DME facility. In this case, you could make the Sacramento VORTAC your waypoint and get that distance information. But let's suppose your GPS is randomly flashing you discouraging messages about RAIM. It's telling you that RAIM is not available. And suppose further that you're riding the rails down the Mobile, Alabama ILS when some good old boy drives his pickup truck into a nearby power pole and knocks out the power to the marker beacon and the compass locator. Oh, whoa, what will you do? Well, dry those tears. All is not lost. Look here at Sims VORTAC. Notice the 050 radial? It goes right smack dab through Whizzle. In fact, this note up here identifies that spot as Whizzle intersection. So you can use the 050 radial of Sims VORTAC to identify your position at Whizzle. And if that isn't enough to make you whistle a happy tune, what will?